Great. Good afternoon. My name is Kelly McGuire. I am the Assistant Administrator at USDA's Economic Research Service, and I'm pleased to be hosting this breakout session highlighting some of ERS data products and data initiatives. This session is going to highlight two of our data products, the Meat Price Spreads series and the Commodity Costs and Returns reports, as well as a new initiative linking food acquisition and nutrition data. We have three speakers with us today. I'm going to introduce all three of them, and then we'll go ahead and get started. Dr. William Hahn will be talking about the ERS Meat Price Spreads data product, which provides monthly average price values and the differences among those values at the farm, wholesale, and retail stages of production and marketing chain for selected cuts of beef, pork, and broilers. Bill is an economist with the Animal Products and Cost of Production branch within our Markets and Trade Economics division. He has worked at ERS on livestock issues since 1986. Dr. Jeff Gillespie will be talking about the ERS Commodity Costs and Returns reports, which provide information on the value of production, operating costs, and supporting information for major field crops and livestock. Jeff is the acting branch chief for the Animal Products and Costs of Production branch, and a senior economist in the Markets and Trade Economics division. He joined ERS in 2016, having previously served as an endowed professor of agricultural economics and agri-finance at Louisiana State University. And finally, we have Dr. Andrea Carlson, who will be talking about a new initiative linking nutrition and scanner data. ERS has linked household and store-based scanner data to USDA nutrition data to better evaluate and analyze the healthfulness of American food purchases. Andy is a senior economist in the food markets branch of our food economics division at ERS. She joined the federal government in 1999, first with the Centers for Disease Control, then with USDA's Center for Nutrition Policy and Promotion, before joining ERS in 2009. Each speaker will talk for about 12 to 15 minutes, leaving plenty of time for your questions. Please use the Q&A feature in the bottom of the Zoom ribbon, and we'll answer these questions after the three presentations. You'll note that this session is being recorded and will be available after the meeting along with the slides from the presentations. And finally, closed captioning is available using the closed caption button on the Zoom ribbon at the bottom of your screen. So we'll go ahead and get started with Dr. William Hahn. If you'd like to go ahead and share your screen, please.
Certainly will. And here we go. Hit the share button, and then we're going to do from the beginning. All right. I apologize today. I've got a new computer and an old camera. The old camera's cord isn't long enough for my new computer, so I'm going to be doing this incognito. All right, so thanks, Kelly, for the nice introduction. Today I'm going to be talking about the meat price spreads data. As I said before, my name is Bill Hahn, and I've been an economist with the USDA Animal Products branch since 1986. So an overview of this talk was general discussion of why and how the meat price spread data were developed, what kind of people use this data, and we're going to look at some of the, look at the data actually. Okay, so why does ERS calculate this? Well, according to the Agricultural Adjustment Act 1946, the Department of Agriculture is supposed to estimate the difference between the retail and farm level values for various commodities in various forms. And so now USDA really started comparing retail and farm prices in the early about 1910-ish, maybe even earlier. I've got some things in my files that date back to 1917. Now, we do have two sets of this price spread data. The meat price spreads, and we'll be talking about that today. Obviously covers meat, includes poultry and eggs. Other agricultural items are covered in what they call price spreads from farm to consumer. And you can find those on the ERS data page or ERS website. Anyway, Now, this meat price spread product is like the second most downloaded data set for the market and trades division where I work. And I get a lot of questions from a wide range of people, including producers, bankers, academics, and others. And this data has been used in a lot of studies. You know, in fact, I've used it myself to meet demand, price transmission. Other people have used this kind of data looking at market efficiency and industrial organization issues. Now let's talk a bit about exactly what we're trying to do with this data. I'm going to be focusing on the choice beef and pork. So the idea here is we're going to price an animal at different points in the marketing chain. You price the whole animal as it leaves the farm, price the whole carcass as it leaves the packing plant. On that level, we also, animals produce both meat and byproducts. So we're going to include a byproduct value on there, to correct for that non-meat part of the animal. And then basically what we're going to be doing for that retail value is what would it cost to buy back all that animal's parts from the grocery store meat case for the most part. Okay, so we're talking about at the retail level, a relatively low value added kind of product with some minor exceptions, bacon and ham, for instance. Now, all this stuff technically is based on what we call a fixed proportion relationship. So we're assuming it takes 2.4 pounds of steer to make a pound of retail beef, 63% dressing percentage on that steer, and 1.87 pounds of hog per pound of retail meat with a 74% dressing percentage. So what we do is take all these prices and make them into a retail weight equivalent. So for instance, the farm value of the steer is actually 2.4 times a live value of the steer. What's the price of a live steer, whole animal, and the farm value of a hog will be that 1.87 times of its live weight price. Our data sources, farm wholesale and byproduct data come from the USDA Agricultural Marketing Service. We're using what they call negotiated prices for farm and wholesale values. Retail prices come from the Bureau of Labor Statistics, the average price data. On a related note, BLS are the people that do the consumer price index. Those numbers were released today, and as of noon Eastern, or 11 where I am, Central Time, we have September numbers up for the choice beef and pork price spread data. We can talk about that later. Okay, so we have this data in our database going back to 1970. I know it exists somewhere even before that, because when I was in graduate school, I actually pulled this data for various kinds of econometric studies starting in like 1960 something, or monthly data going back to 1960 or so. Well, what 1970 is what we got in our database, so I'm showing this here. Now, right, in this chart, normally the data that we show on the website is the nominal prices. And I've decided to compare these things over time, so you have this long time series, by deflating it by the consumer price index. All right. Now, one of the things you'll notice is that the highest real prices were there in the early and later 70s for most of these products. And until the 90s or so, or late 90s, largely these things were roughly declining. Now, since the 1990s, the retail price of beef has been growing more rapidly than inflation, and the wholesale and farm value of livestock, farm value of livestock, and the wholesale value of beef has been going, well, went sideways for quite a bit, and then starting in about 2010, both of them started to increase. Past couple of years, you see a big divergence between that gross farm, or the farm value, and the wholesale value for steers. Do the same thing with the pork values, although now generally the same type of story as with beef, although the movements over time aren't quite as, extreme. Again, we got, in this case, pork was roughly steady from in the 90s to the early 2000s relative to inflation. Retail value has been taking off. After that point, late 2000s, the farm and wholesale values started increasing a bit as well, although obviously with some fluctuations here for the past few years. Last year, you'll see some unusually high prices for both of these guys. Now, okay, choice beef price spreads. So part of this Agricultural Adjustment Act thing is like compare the values at different levels. And so on this chart, I'm showing the three price spreads that you'll find in our data products. Farm to retail, that's the difference between the farm, in this case beef, the meat value of the steer versus the retail value of the steer's meat. All right. Now that figure was relatively steady for decades, but since about the 2000s, that farm to retail spread has been increasing. Okay. Now, the wholesale to retail part of that spread has been roughly increasing for the past 50 years, or a little over 50 years. Okay. There's some fluctuations in there, but that's what's happened. Until like 2012, that farm to wholesale value was decreasing, or not increasing as fast as inflation. In some cases, actually declining relative to inflation. So it's steady there in the early 2000s and late 90s, and lately has started to take off on us. Now, again, we see that same kind of pattern with pork. Although, well, as the case on these values, the farm to wholesale value has been a little less exciting in the past couple of years. But that wholesale to retail thing's been growing fairly dramatically in over the past 50 years. In fact, looking at this thing here. Yeah, sorry, back and forth. One of the interesting things about this, like the first few years in this data set, is that there was more cost. The farm to wholesale cost for pork was greater than wholesale to retail cost for pork. Okay. Now I'm going pretty quickly. So you can find these things on our website. Typically, when you type the word meat prices into your browser, the first thing that comes up that's not an ad will be the meat price spreads data page on the ERS website. Through that, they've got some documentation, links to documentation for the thing on our documentation page. You can find a beef and pork values and price spreads explain thing that I wrote in 2004. And that'll go into a lot more detail on how these things are calculated, and also does some statistical analysis of these prices. And I'm wrapping it up early, yay me.
Great, thank you very much.
I'm going to figure out this. Yeah, I'm going to stop sharing.
Okay, that sounds great. And you're welcome to go ahead and start putting your questions in the Q&A feature, and then we'll take those after all three presentations. So turning next, we'll hear from Dr. Gillespie. If you'd like to share your screen.
Okay, can everyone see my screen there?
I can see your screen and I can hear you, so you're good to
Okay,
go.
thank you. All right, I'm Jeff Gillespie, and today I'm going to be talking about the ERS's commodity cost and returns data product. And through this commodity cost and returns data product, we provide estimates of commodity cost and returns for 12 different commodities. I'm going to talk about that. We're going to talk a little bit about how we do it, how we present it, and some of the different kinds of research we conduct with this, as well as who uses these data. Let's see. I am not getting this to, here we go. Okay. Okay, so the motivation for the CAR data is the Agricultural and Consumer Protection Act of 1973, where we were to conduct a cost of production study of the wheat, feed, grain, cotton, and dairy commodities under the various production practices and establish a current national weighted average cost of production. And this study shall be updated annually. You can see some of the other verbiage about that. But mandated reporting of these data is part of permanent Farm Bill legislation. So we do this on an annual basis. To give you a bit of an overview of the Commodity Cost and Returns Project, we estimate cost and returns for 12 different commodities annually, and we've been doing it since 1975. In addition to the national and regional accounts for the 12 commodities, we also estimate provide state estimates for milk as well. These estimates are based largely on data from commodity surveys as part of the Agricultural Resource Management Survey, or the ARMS survey, as many of you may have heard. The ARMS commodity surveys that we use for these, they're conducted every 48 years on a rotating basis for each commodity. So the ARMS is conducted on an annual basis, and we have ARMS surveys that go out to farms of all types every year. But we also target certain commodities and on a rotating basis, and those surveys are the basis for which we collect the data for our commodity cost and returns surveys or analysis. So, for instance, corn. We surveyed in 2016, and we will survey it for 2021. So that was on a 5-year rotation this time around. So we have estimates for 2016. We'll have estimates for 2021 for corn. And then those estimates for the years between those surveys, 2017 through 2020, those will be based on updates of the 2016 estimates based on price, acreage, and production changes for those years. And these methods that we're using for estimating commodity cost and returns are those that were recommended by the American Agricultural Economics Association Task Force in the 90s. It was a task force developed to determine best practices for estimating commodity cost and returns in for agricultural production. These are the commodities that for which we estimate cost and returns estimates every year. And you'll see 9 crop commodities there and 3 livestock commodities. Those that are in black, those are the mandated estimates. The green estimates are not, the ones that are in green are not mandated, but they are important nonetheless. They are very important economically, and of course they compete with the mandated commodities for agricultural resources. And so you see the latest survey of the year out to the right of the commodity. That's the latest survey for which we have estimates made already. And so you see for the crops, we have cotton, grain, sorghum, soybeans, wheat, corn, oats, rice, peanuts, and barley. And for livestock commodities, we have cow-calf, dairy, and hogs. And we also list some upcoming data there that we're either working on those data to develop those cost and returns estimates, or those data will be coming soon for us to work on those. This chart shows the data collection process for the 2021 ARMS. And these are the data that we use to develop our cost and returns estimates. ARMS is conducted, it's jointly by National Ag Statistics Service, NASS, and ERS. Phase 1 is a screening sample where we determine which farms are still in business and which ones are producing a particular commodity. Phase 2, we go to the farms and ask them detailed questions about their production practices and costs on the field level. So we'll choose a particular field. For instance, if it's a rice farm, choose that field and find out every time a machine crosses the field, various input usage, fertilizer, chemicals, others. And then phase 3 is at the whole farm level. And so there are 4 different versions for 2021 ARMs. There's the general farm cost and returns version, which goes to farms of all types, producing all kinds of different commodities. Then there's the milk cost and returns, which it goes to dairy farmers, and we use those to develop our cost and returns estimates. And then there are 2 other versions of phase 3 as well, which are the corn and the rice versions. And those, for the corn and rice, we use both phase 2 and phase 3 to estimate our cost of production estimates every year. Okay, what are some approaches that we use for commodity cost and returns estimation? Well, there are several. The first is direct costing, and that's where we take purchased input costs directly from the survey. We just ask, how much did you spend on seed, fertilizer, chemicals? And examples do include purchased seed, fertilizer, chemicals, and custom operations. So that's one of the ways we do it. Another way we estimate costs is through valuing input commodities or quantities, excuse me. Farm supplied or homegrown input quantities from the survey are valued using relevant prices. And examples of that include homegrown seed and feed, unpaid labor, land, and manure. For instance, for our livestock, we will determine how much of the homegrown feed is being fed. And then we know how much is being fed, and then we can put a price on that based on the market price for that feed. So that's the valuing input commodities. Another way we do this is through indirect costing. We use engineering formulas along with our survey data to estimate machinery and equipment costs. And so the examples of these include our machinery and irrigation fuel, repairs, and capital. So we know when from our survey, when every time a machine goes across the field, if it's a tractor and an implement, we have engineering formulas that we can determine how much fuel would have expected to have been used, the repair costs, et cetera. And then finally, there's the allocating of whole farm expenses. And for some expenses, it's hard to just allocate to a particular enterprise on the farm. You think of a farm that produces corn and soybeans and hogs, and you have insurance costs. How do you allocate those insurance costs to each one of those different commodities? Well, the way we do that is the rule we use is the gross margin of the commodity relative to the whole farm gross margin. Okay, this slide shows you some of all of the expenses that are that we have in our crop accounts, and I'll just go through a couple of these. Of course, we have the gross value of production at the top. We have our operating costs, which include seed, fertilizer, chemicals, and others. We have our allocated overhead, which would include hired labor, the opportunity cost of unpaid labor, the capital recovery of machinery and equipment, and others. And then, of course, we total up the costs. We then develop an estimate of the value of production less the total costs, and an estimate of the value of production less the operating costs. And how do we present these on the ERS website? Well, this is how we do it. We have these downloadable pivot tables that we place on the ERS website that show our cost and returns. And you can see here, this is for corn. The last survey base year was 2016. And so this shows 2016 through 2020, but this goes all the way back to you can find data all the way back to 1975. And so your operating costs, you see the feed, seed, fertilizer, chemicals. I've cut off the rest of it below, but on the website, you could see that. You can also see those tabs at the top where if you don't want to look at the US total, you can go and look at those for the Southern Seaboard, the Heartland, the Prairie Gateway, Northern Plains, and others. Another way that we present these data is through data visualizations that are interactive, provided on the ERS website. This is just an example of one of the many charts that you can look at on the ERS data visualization for commodity cost and returns. What you see here is each one of these bars is a different cost for a different region. And the blue, those represent different operating costs, and the different shades represent different operating, like the specific operating costs: fertilizer, seed, fuel and lube, this sort of thing. And then there's the allocated overhead down below there, which is in orange. And so that's just an example of how you can use, look at some interactive data visualizations on our website. But we don't stop there as well with by just showing the summaries of the data. We also can do some analysis with these data that's pretty interesting. Here you see a chart that shows that farms with greater farm acreage, corn acreage, have generally experienced lower production costs per bushel. And so here you see 4 different years of data: 1996, 2001, 2010, and 2016. And each bar looks at it, shows a different farm size in terms of acreage. And so the light blue, it's the farms with less than 200 acres, and that's their cost per bushel. The dark blue is on the right-hand side of each one of these, is more than 1,500 acres. And you can see in general that there's lower costs for larger scale farms in this case. Another example here is for dairy. This is net returns by herd size from 2005 to 2018, some analysis that we published recently in a report. The light blue at the bottom is the net returns for the 50 to 99 cow herds in dairy. The darker blue at the top is for the 1,000 and greater cows herds. And of course, you see higher net returns for the larger scale herds. And so that's another way we can look at, take these data and do some nice analysis with them. We've published a lot of reports on using these data. Here are just a few of them over the past 6 or 7 years. We've got characteristics and costs of corn farms. We have, that was just released a couple of months ago. We have organic field crop profitability. This third one up at the top, production costs and export competitiveness. We were able to compare US cost of production with those in some other countries, Argentina and Brazil, for corn and soybeans. We've looked at changing economics of hog production, changing costs in rice production, and dairy farm costs and consolidation. So there are all kinds of, lots of different research projects that one can enter into with these data to provide some good information. There's a lot of interest in the data product as well. Users of CAR, the commodity costs and returns, include government agencies, policymaker staff, academic research and extension staff, farmers, input providers, ag consultants, the press, and others. And we get a lot of questions from these. Our web stats show that the ERS commodity cost and returns and the milk cost of production web pages were visited more than 50,000 times last year for an average of about 138 views per day. Here are some things that we've done recently. I won't say much about this, but we have moved to fewer Excel files and replaced them with pivot tables. And the pivot tables recently added just this year were for milk size and state accounts. We've also had some data visualizations for a little while that I showed you a little while ago. This month, for the first time on October 1st, we released added data visualizations for hogs, milk, and cow-calf costs of production. Okay, so that's that sort of wraps it up. Here's where you can find information on ARMS and cost and returns estimation. So thank you. And I'll stop sharing here.
Great. Thank you very much. That was really helpful, and then lots of good information. If you're just joining us, I just had mentioned earlier, feel free to go ahead and put any questions you might have in the Q&A feature in the bottom ribbon of the Zoom screen, and we'll answer those questions after the presentations. So our next presenter is Dr. Carlson. If you'd like to go ahead and share your screen. I can see it, but you just need to unmute yourself.
Here I was being so polite to my colleagues.
There you go. You're all set. Thank you.
All right. So, is it more expensive to eat healthy? Is the current cost of food related to health outcomes? What are the major factors that influence food choices? These choice questions are being considered in both the nutrition and social science literature and may be of interest to policymakers. By linking data sets together, we can better adjust. By linking existing databases together, we can better address these questions. And something weird happened. I can't find my notes. There we go. The work I'm going to talk about today is not a solo project, and I need to acknowledge the team. I'm going to start with an example that could not have been done without linking data. The Agricultural Improvement Act of 2018 required the recent update of the Thrifty Food Plan, or TFP, market baskets. The TFP market baskets are types and quantities of foods that households can purchase at a minimal cost to prepare healthy meals and snacks. The cost of the market baskets is inflated each month using a set of CPIs for food. And the cost of the June TFP market basket forms the basis of the maximum allotment for the Supplemental Nutrition Assistance Program, or formerly known as food stamps, for the following fiscal year. Comparing the inflation-adjusted cost of the previous and the new market baskets resulted in a 21% increase in cost. Now, making this change required significant evidence. For starters, the 2018 Farm Act required that the TFP market basket update use current food prices, current food composition, that's the nutrient content, and consumption patterns and dietary guidance. USDA nutrition data has been developed over decades, and there are easy links between the last three sets of data. However, estimating current food prices meant linking retail food scanner data to the USDA nutrition data, and this was not an easy task. In order to conduct this type of research, I'd like to introduce the Purchase to Plate suite. The Purchase to Plate suite has multiple goals. The first is to enhance research capacity related to the economics of food and nutrition. And the second is to support USDA projects, such as the update of the Thrifty Food Plan market baskets. And then there are 3 other USDA food market baskets that also need to be updated, and related research supporting USDA goals. Before describing exactly what is in the suite, I'm going to provide a very brief overview of the data sets that are linked in the Purchase to Plate suite and how we link them. To create the suite, we linked food scanner data, and we linked USDA Food and Nutrient Database for Dietary Studies, which is also known as the FNDDS. For almost 2 decades, USDA has acquired food scanner data to conduct food economics research and support USDA programs. We currently obtain these data from IRI, and they include both retail point of sale, or POS data, and this is the purchase transaction records collected from store point of sale systems. These data also include the household scanner data. This is where households scan their purchases from a variety of different stores, and the data also include household demographics. Both data include very detailed product information at this barcode level, and it also includes store information about the stores where the consumers purchase the goods or that we have sales data from. Our sister agency, the Agricultural Research Service, maintains nutrition data that some have described as the best in the world. One example of these data is the Food and Nutrient Database for Dietary Studies, or the FNDDS. These data contain nutrient values for foods reported eaten by Americans. It also includes a set of recipes for nutrient calculations. Now, I have recipes in quotes because they are developed for nutrient calculation, not for actually preparing food. So as a result, the ingredients in the recipes are not necessarily purchasable in stores. And an example of that might be toasted white bread. Every recipe, such as garlic bread, toast, any kind of casserole that includes toasted bread, they all use that same ingredient. This is so that there is consistency in the nutrient content across all of the foods. The FNDDS are updated every 2 years. There are new foods reported in the surveys. There are also changes in the data collection methods. And there are, especially in the last 10 years or so, there have been major revisions to the underlying nutrition databases. To illustrate some of the problems we faced in creating the links, it helps to understand what the items look like in each data set. On the surface, it might not be too bad. After all, we have pomegranates and pomegranates and peas and peas and carrots and eggs and eggs. However, in the scanner data, the pomegranates come with that outer shell and stuff we don't eat, and they come, and you can buy just the individual aerials. Carrots come in a huge variety of ways, and peas generally come in fresh, frozen, and canned, and other varieties. In addition, in the FNDDS, we have dishes that people actually eat, probably based on some of which they prepare at home. And these are going to be based on the ingredients that were purchased. To establish the matches, we use probabilistic matching, which is a statistical process where every possible match is given a score based on a search table. And the highest score is the match. Now, although this is a new data product open to the public, we have done a few rounds of this linking. So to begin a new update, we start with the search table developed for the previous update. So each update is of different years. Probabilistic matching is then used to establish the matches. Because the food descriptions between the two data sets are so different, and our need for very low error rates because of the importance of these data in policy making, nutritionists still need to review the matches. They set the correct matches aside and then revise the search table, and we go back again through the loop. After 2 to 3 times through this process, we generally find it more efficient to manually link the remaining UPCs to the FNDDS codes, and then we end up with the final match. The final step in developing this crosswalk is to create yield factors that convert the purchased weight of foods into the edible weight found in the USDA nutrition databases. This is similar to the wholesale to retail weights that were talked about earlier. So for the retail to edible weights, we have to take out the weight of skins, peels, shells, seeds, and bones. And in some cases, we have to adjust the weight for the cooking losses or gains. The purchase to plate suite is shown in green and has 2 major components: the purchase to plate crosswalk and the purchase to plate price tool. The purchase to plate crosswalk allows researchers to use scanner data to measure how well retail food purchases comply with federal dietary guidance using the Healthy Eating Index, which is a measure that was developed by USDA and the National Cancer Institute to measure the healthfulness of dietary data. The price tool, on the other hand, allows researchers to estimate food costs for dietary recall data. So this is the cost of the food as it appears on the plate. using any subset or the entire set of scanner data. In addition, because the scanner data has geographic codes, particularly the household data, we can use FIPS codes or county codes to link these scanner data to the ERS Food Environment Atlas, which contains a lot of information about what food is available in the county, and also some social and demographic information about each county. We have also recently linked it to the Centers for Disease Control data on community health. And you could link it to agricultural statistics and whatever else you can think of. And using those barcodes, we can link it to the USDA Branded Foods Product Database, which is a database that uses, that the food processors and the food people actually upload all of their product information at the UPC level into this. So we have current nutrition information, although we don't have all of that, what we have in FNDDS, but we can link to that, and that provides additional information for conducting research. Currently, we are using the applications first, as I mentioned, in the USDA food plans. The 50 food plan is done and out, and then the other food plans are yet to come. And then we're also using this in a variety of research projects, such as what is the cost of low, mid, and high quality diets? And for quality there, we're using the nutritionally the healthiness of the diet. We're also looking at shifts in US food preferences. There's a group that's using this to estimate climate change induced food costs and the relationship between store type and diet quality. An important one right now is because dollar stores are becoming an important source of food for low-income Americans. And there is at least one NEFA-funded grant, and it's called From Scarcity to Prosperity, Nutrition and Food Spending Goals and Constraints for Low-Income Americans. That one is using the food prices that we talked about. To access these data, one of the problems is that scanner data are proprietary data. We purchase or we obtain the data, and they can be used for projects of interest to USDA, and that includes projects that are funded by USDA. And there's more information on the ERS page. Actually, if you search for ERS scanner data, that will bring this page up fairly close to your top. Some of the data that's linked to it, like the FNDDS and the FPED and FPID, which I didn't talk about, but it's used for basically that conversion, counting up the number of cups of fruit and that kind of thing that is used for the Healthy Eating Index. And then NHANES and What We Eat in America are as the dietary recall data that I mentioned. And very exciting, coming soon, we will be putting on the ERS website the national average prices for NHANES, so that if you use dietary recall data, you can use that. And eventually, we're also planning to put the crosswalk up. We have some issues to work out with that. And so I hope you now understand the Purchase to Plate suite and are thinking maybe if you're a researcher about how to use it for your own research, and I'm happy to address questions. Thank you.
Great, thank you, Andy. That was really helpful. A great overview of some different data products and initiatives here at ERS. And we do have some time for a few questions if folks would like to go ahead and put those in the chat. I do see one here, so I'll go ahead and get started by reading it. And this is for Jeff. The question is leverage and debt considered in the commodity costs and returns? Obviously, that varies from specific farm to farm, but is there an aggregate assumption?
No, we don't. We really aren't considering that. We're really just looking at what does it cost to produce the commodity, and so. But now there is some information in the RM survey that one can where we ask about debt. But yeah, not within the commodity cost and returns. We don't do any. We don't have any estimates there on leverage or debt.
Great, thank you. So that was the one question we had. I'll let you take some time to perhaps think of other questions that you might want to ask. I have a couple of that I'll just pose myself. So Bill, I don't know if you mentioned this, but if you could clarify, how frequently are the meat price spreads data updated?
That's a good point. We do it monthly, and our retail prices come from Bureau of Labor Statistics. Those are the last set of prices we get. So typically it'll be the same day as they release the consumer price index and that data.
And so then there's the lag between when those data are, the CPI data are released and when we update our meat price spreads is it short? What's the lag? Or how recent are the?
So the BLS data is released at 8:30 Eastern, and we get it up by noon Eastern.
Right. So that's always a busy morning, I'm sure.
Yeah.
And I also wanted to note that I overlooked at the beginning that we also have our administrator here with us today, Dr. Spiro Stefano. So I think he's going to turn his camera on, and so it's great to have him here as part of this breakout session as well. Thanks, Spiro. A question just came in. I think this is probably directed at you, Andy. How do we account for risk, which has certainly become a more important cost because of the food recalls?
Right. So in these national average prices, we just calculate the cost of the food. So this is only the cost of the food. It does not take into account things like risk, like from a recall, or it does not include food that is purchased but not eaten, any of those kinds of things. However, we can't really do all of them, but we highly recommend that individual researchers account for all of those things, as appropriate for the research project. And in policy decisions, that's also done.
Thank you. Jeff, I was wondering if you might say a few words about how we decide when we will do estimates, new cost and return estimates for different commodities, sort of those discretionary commodities that we have in our portfolio. You could talk a little bit about that decision making.
Sure. Yeah, it's about on a 4 to 8 year cycle between those surveys, and it really the way we determine that is part of it is how fast we're seeing technological change for a particular commodity. Some of the different commodities you're seeing pretty rapid technological change, and also if they're major commodities that there's a major interest in, corn, dairy, you want to be able to do those on a regular basis, is fairly often. It's primarily on the basis of how quickly technological change is occurring. You want to make sure that your cost and returns estimates are as up to date as possible using the most recent technology. We update we hold that technology constant between the survey years, and just update using with prices and yields and so on and so forth. So it's important that we update the technology on a fairly regular basis.
Mm-hmm. Great, thank you. Another question came in again. I believe this is directed at you, Andy. You mentioned the development of national average food price estimates. Is there any intent to tie consumer food price estimates to regional, state, or to county scales?
We don't do that. We're not going to do that on the national average prices. And the reason is because it relates back to the IRI and proprietary data. However, The reason it's called a tool is that anybody can go into the scanner data and calculate your own prices and conduct a study that way. The other thing is these prices are related to NHANES, and in the public use file of NHANES, you do not have any geographical information. A final issue with geographic things is that the retail data, we are developing store weights, but it's not necessarily represented at even a county level. So when you connect county data to it, you use it in a regression analysis. It's not necessarily appropriate to use it as an outcome variable.
Thanks very much. I'll give it just another, we do have a couple of more minutes here if folks would like to add any more questions to the chat. This has been a really great session. It's always nice to hear the descriptions of the various data products and the advances that are on the horizon. Well, I think if there are no further questions, we can conclude the session. I appreciate everybody joining us. We do have a reminder here to folks that you will be receiving an evaluation form with a link on Friday since you've registered for the workshop. And we definitely appreciate all of your feedback, suggestions for future topics. These meetings are held twice a year. And so we like to highlight different topics and data products in each of them. So if there's anything that's of particular interest, please let us know. So thank you very much and have a good afternoon.